math has been driving you crazy, or if you're finally admitting you're lazy, and your test grades have been dropping, it's time to get your arrows popping. Hello, ladies and gentlemen. This is Mr. Witt with Fort Bend Tutoring, and today we have part 2 of our geometry end of course final exam review. How is everybody doing today? We have Tony and Noah in the house. We have the chosen creeper in the house already, ready to go with some geometry. Just want to let you guys know that I would love for you to subscribe to Fort Bend Tutoring, as we like to bring you fresh, new, free math tutorials from Fort Bend Tutoring and Mr. Witt, myself, and we also love to share our knowledge. You know, it's just part of our purpose. Is why we're here. We like to help people. Okay, let's just get that on the table right now. Okay, and so go ahead and share the stream with your loved ones. The people you know that need some help in geometry. Yeah, go ahead and share the stream with those people. Also, click on the bell icon next to the subscribe button. That'll let you know when we're live with new content, when we're uploading new videos, to share the love. There you go. And also like the stream, okay? So there you go. That's what we ask of you to do for us. And we have problem number 25, just picking up. This is part 2 of our geometry, guys. We're just picking up with where we left off at. That is right. And we're looking at problem number 25. It says, find the missing angle measures. The diagram is not to scale. So what we have before us is we have several angles showing. We have a polygon showing here, and it's a 4-sided figure, right? So one thing you should know about any 4-sided polygon is that the sum of the interior angle measurements is going to be 360. See, you can use the interior sum formula, okay, in order to figure this out. The sum of the interior angles formula for a polygon to make that happen. All right, we got Think 2 in the house. We got Chosen Creeper with the angle measurement already. Okay, so let's just look at that real shortly here. We know that n minus 2 times 180, all right, is going to be the sum of the interior angles of a polygon. So if I have a 4-sided figure and I just plug in 4 for n, then we would end up with 4 minus 2 times 180, and then 2 times 180 is going to, oh my goodness, the 8 on that 180 was ugly. This was not much better, but you would end up with a total of 360 degrees for this interior measurement. So let's keep that in mind, all right, that we know that the total measurement of our quadrilateral here, of the 4-sided polygon, must be 360 degrees. Yeah, so we're going to keep that in mind, all right? So let's go ahead and see what else we can do with this information. And that is, because we have a linear pair here, we can solve for y quite easily, because the sum of 124 degrees and y degrees must be equivalent to 180 degrees. These two angles here are supplementary. So therefore, we can say that 180 degrees, if I can get my ink going here, and we want it in black. There we go. We have 180 degrees minus the 124 degrees. Let's go ahead and figure that out. Let's go ahead and figure this out. The 10 minus the 4 gives me the 6. The 7 minus the 2 gives me 5. So we can confirm, just as Chosen Creeper has already stated, that y degrees must be 56 degrees. It has to be 56 degrees. It must be, because all we had to do was subtract the 124 degrees from 180 degrees in order to end up with our result for the y degrees, because these two angles are linear pairs. They must add to 180 degrees. They must be supplemental. Yeah, so now we know that this is 56 degrees. But recall that all 4 degrees of the polygon must be equivalent to 360 degrees. So what we're going to do is we're going to say that we have the 125 degrees. We have the 65 degrees. We just proved that y is 56 degrees. we're going to add those together and then subtract from 360 in order to find out what our result for x degrees must be. So this is going to give us 16. We're going to carry the 1 here. Yes, we are. That's going to give us 14, right? We had 1 plus the 3 is 1 plus the 2 is 3. 3 plus the 6 is 9. 9 plus the 5 is 14. Carry the 1. We end up with 246 here. Then subtract that 246 from 360, and that'll give us our result. Yeah, that's what we'll have here. Let's go ahead and subtract the 246 from the 360, and let's get this popping on and popping here. There we go. All right. Is that correct there? We have 114 degrees. Is that correct, guys? Chosen Creeper, talk to me. Is this the correct measurement here? If we're adding the 125 degrees, the 65 degrees, and the 56 degrees. All right. The angles that we already know from our diagram. That gives us the 246 degrees that we must subtract from the 360 degrees, the total amount that we had for the interior angle measurements of our quadrilateral. Amen, amen. So we should end up with 114 degrees for our value of x, and done. There we go. All right. Well, Chosen Creeper says that that's correct. Tony is saying that's correct. I appreciate that, guys. Let's go ahead and clean up my mess a little bit here. All right, there we go. We didn't have much room for our scratch work, but that's okay. Okay, that's all right, because we're going to red box these answers right here. That's exactly what we're going to get. We're going to get it cleaned up. That's okay, Chosen Creeper. It's all right. You're not clumsy today. You're getting things warmed up. You're just warming up today. That's all you're doing, sir. Just getting things warmed up. So that was problem number 25. Getting the geometry review underway. Ryan Brown says, I did the music for your videos. I need you. Oh, you did some music for the videos? Let's keep those tutorials popping. All right, Ryan. Is that right? You like the music for the videos. You want to do some music because I know you didn't do the music for the videos. That was somebody else. That was my student that hooked me up with that. All right. Good deal. But you want to do some music for the videos. All right. You can go ahead and hit me up. The email you can find is on the YouTube channel. There you go. YouTube channel. There's an about on the YouTube channel. You can go ahead and use that email address, Ryan, so you can contact me about some music. All right, let's go ahead and go with number 26, guys. It says to find the volume of the shape. What we are looking at in problem number 26 is a triangular prism. That's exactly what we're looking at. A three-dimensional object here. And we're going to be finding the volume of this shape. Now, notice over here, I already have my cheat sheet ready to go, guys, because I'm letting you guys know that in order to find the volume, it's going to be equivalent to the area of the base. See, this big B here, the big B, stands for the volume of the, stands for the area of the base times the height of the prism. That's exactly what's going on here. So that's what we're going to find out first. Notice that our bases are going to be the triangular shapes here. Okay, so the bases are going to be the triangles. We need to find the area of that triangle and then multiply that area times the height of the prism. That's how we find out what the volume of this prism is. So let's go ahead and note that in order to find out the area of the base, we'll be using 1/2 times the base of the triangle times the height of the triangle. That's exactly what we'll do. And so in figuring this out, guys, we'll say that we'll have 1/2. The base of our triangle is going to be 1 meter, whereas the height of the triangle is 2 meters. So if I were to multiply all this out, and we'll just go ahead and cheat here, we'll just go ahead and take the easy route and take 1/2 of 2, which is 1. And therefore, 1 times 1 gives me an area of 1 square meters for the base. We end up with 1 square meters for the base. That's what we have here, guys. All right. So that being the case, we know that the volume of this triangular prism is going to be the area of the base, which we just found out, we confirmed is 1, times the height, which is 17. So multiplying 1 times 17 gives you a total volume of 17 cubic meters. And this is our answer for problem number 26. And we are red boxing it, ladies and gentlemen. That's exactly what we're doing. We are red boxing our answer. Yeah. So anytime you have a triangular prism here. Oh, yeah. Anytime you're dealing with a prism, in order to find the volume of that shape, you're going to be multiplying the area of the base times the height. And keep in mind that your bases, all right, are going to be always between the rectangular faces. So notice that we have rectangular faces here, all right, in between these bases that are triangular. And there you have your prism. You have rectangular faces when you're dealing with prisms. Oh, yeah. There you go. There you go. And I got my unit of measurement to the third power when you're dealing with volume. When you're dealing with area, the unit of measurement will be to the second power. When you're dealing with circumference and perimeter, it's going to be to the first power. All right. I made a boo-boo on that first part of the geometry quiz. I believe it was like the second or third problem, guys. The unit of measurement was supposed to be to the first power because we were dealing with perimeter. All right. And I made this mistake because it's live. Okay. Things are on the fly when you're dealing a live stream, when you're dealing with the live stream here. All right, so I make a little mistakes here and there, but you guys are supposed to be checking for me, okay? So you make sure you guys are checking my work as we're doing this, people. That's what you guys are here for, to help one another out, to help me out. Problem number 27. We have find the surface area of the cylinder in terms of pi. So our general formula for finding the total surface area of a three-dimensional object is going to be the perimeter of the base times the height, all right, plus 2 times the area of the base. There you go. There you go. So once again, in order to find the surface area of the cylinder or three-dimensional object, you'll be finding the perimeter of the base times the height of that three-dimensional object plus 2 times the area of its bases. And because we're dealing with a cylinder, we can dial this in even more so as far as the formula is concerned and say that the total surface area must be equivalent to the perimeter of a circle is its circumference. So we can say that it's going to be 2 pi r times the height of the cylinder here, plus 2 times the area of a circle, being as though the circles are my bases, are going to be pi r squared. And instead of the parentheses there, let's use the pi r squared. I hate that pi. All right, let's have a better pi. All right, there we go. So we're going to use this formula for our total surface area of the cylinder. So all I'm doing here is I'm defining the fact that since I'm dealing with a circle, that the perimeter is equivalent to the circumference of the circle, all right, times the height plus 2 times the area of the base, which happens to be a circle, and the area of a circle is pi r squared. So we end up with this formula right here. Let's go ahead and then plug in our values. We'll have 2 times pi. The radius of our base is 8 times the height, which is 11, plus 2 times the area of the base, which is going to be pi times the radius squared, which in this case is 8 squared. And so here we are looking at our setup. That's exactly what we're doing. Oh, yeah. So continuing on, we're multiplying. We'll have 8 times 11 is 88. And 88 times 2. Let me go ahead and make sure I do this right because you guys are not helping me out here with checking my work. All right. There we go. We got 176. Is that right? 176 pi. Okay, let's get that out of the way for now. So we have 176 pi, and then multiplying 2 times 64 is going to be 128, because we know that 8 squared is 64, times the 2 gives us 128 pi. All right, there we go, on our way. And now finally, we'll need to add these together. All right. JV says, thanks for the tutorials. Need to go to sleep. I understand, JV. Thank you for chiming in with us. We appreciate you stopping by. I know I do. So we're going to be adding these two values together, guys. So what is this? We have 176 plus the 128. Let's go ahead and figure this out. We'll end up with the carrying that. We got the 4 carrying. We got the 10. We're going to carry that. We got, is it 304, guys? Is it 304 pi? We end up with 304 pi inches cubed for the volume. Excuse me, no. Let me get my lie right. There we go. It's squared because it's dealing with area, guys. It's surface area. So it must be to the second power. Our unit of measurement must be to the second power. It is in terms of pi. There you go, Chosen Creeper. 304 pi inches squared. What's going on, Sauron? Ansari is saying hello. Good to see you there, Sauron. Thanks for stopping by today. And hello to you. So that's problem number 27, guys. When you're trying to find the surface area of a cylinder, we're going to use the formula 2 pi r times h plus 2 pi r squared. There we go. Chosen Creeper coming in with an approximation to the 100th place after multiplying in that value of pi. But since they said to leave it in terms of pi, we're good to go as it is. What's going on, Simone? How you doing? Thank you for stopping by today, Simone. In the house, guys. Simone is in the house. And that was problem number 27. Let's move on. Let's keep this thing going here. Let us keep this thing going. Good deal. All right. And we got Tony in the house with a donation today. Appreciate that donation, Tony. Every little bit helps. Appreciate that. That's what's going on. Let's go ahead and give Tony some love here. Tony and Noah with a donation this day. All right. What's going on, guys? Appreciate that donation. I definitely appreciate that donation. And speaking of which, guys, you guys can donate using the super chat. It's at the bottom of your chat screen there, the live chat. And you can also use the donation link that's found in the description box. Either way is a good way to donate to Forbidden Tutoring. What's going on, Jamila? How you doing? Let's go ahead and check out what we have going on here for problem number 28, guys. It says the lateral area of a cone is 103 pi centimeters squared. The radius is 37 centimeters. Find the slant height to the nearest tenth. So what we have here, guys, is we have our formula for the lateral area of a cone, which is going to be pi times the radius times the slant height. That's what this L represents right here. It's going to be representing the slant height, whereas the R represents the radius of the base of the cone. And we're going to solve for the slant height. Let's check that out. So they're already telling us that the lateral area itself is 103 pi centimeters squared. So I'm going to replace that lateral area with that value of 103 pi centimeters squared. Saron says your videos are the best. Thank you so much, Saron. I'm doing my best. I'm doing my best to give you guys good content here. And then on the right side, we'll have pi times the radius, which is already given to us as 37 centimeters. And what we don't know is this slant height that we'll be solving for here. So this is going to be my setup. Notice that I'm using the formula that's given to us in this problem, that the lateral area is equivalent to pi times the radius times the slant height. And I'm replacing the given values into that formula. All right. Jamila says she's doing good. How am I doing? I'm doing great, Jamila, because today I get to spend time with you. How about that? It doesn't get much better than that. So I appreciate you stopping by, Jamila. We know you're a busy lady. So I'm going to go ahead and simplify the right side here. I'm going to rewrite it as 103 pi is equivalent to 37 pi times my slant height. And from here, I'll be dividing both sides by 37 pi. That's exactly what, that 7, it's not going to fly. There we go. We're going to fix the 37 and make it better. There we go. So on the right side, that 37 pi just cancels out. So now we have the slant height being equivalent to the result, the quotient of 103 37ths. However, notice that our directions say that we need to find the slant height rounded to the nearest tenths place. So let's go ahead and do our division here to figure out what that value is. So we have 37 going into 103. We'll show our decimal here. We'll need to go out to the hundreds place to round to the nearest tenths place, most likely. And so the 37 will go into 103. That's going to be twice, right? Because 2 times 37 gives us 74. We'll go ahead and subtract from here. We'll need to borrow, guys. We'll need to borrow. Let's make this borrowing happen. There we go. We'll end up with a 6 here. This is going to be a 2 here. We'll bring down a 0. And we'll say that the 37 will probably go into that value about 7 times. Yeah? All right, let's figure that out. We have 37 times the 7. That gives me 49. Carry the 4. That's 21 plus 4 gives me 259. We got real close with that one. There we go. We'll then subtract. Get this out of the way. We'll then subtract here. We'll end up with 1, add a 0. Fix it. Add another 0. And then 37 goes into 10. Yeah. It's going to be like 0 times, right? There you go. It's going to be like 0 times. Okay. Did I miss something? I think I'm missing something here. Something looking a little screwy, guys. Something's looking screwy. 37 times 7 is 259. That part is cool. The 103 minus the 74 is 29, guys. See, y'all supposed to be having my back on this. Here. That's 74. Oh, yeah, it's 13. See? Can't stand it, guys. Let me slow down a bit. Let me fix it. We had 37 going into 103. And you wonder why people say they don't like long division, right? Situations like this. All right, so then we're going to borrow, guys. That's the 9. That's going to be 13. That's what I was missing. 13 minus the 4 gives me 9. That's 2. That's a 0. There we go. Better now. Okay? And so we're not going to get any closer than that 259 going in there for 7 times. We'll then subtract. We got our 10 minus the 9 is 1. We got that. It's going to be 3. We're going to add a 0 here. And then that's going to go in there, guys, approximately 8 times. There we go. 8 times because we know that the 37 times the 8 is going to give me 296. And so we can round, once we have this, to the nearest tenth. And so our slant height, guys, is going to be 2 and 8 tenths. That's what we got. We got 2 and 8 tenths for our slant height, and that's going to be to the first power is going to be centimeters. Good deal. Done and done. And I am running away from this problem because that was ugly, because I was messing up on my long division. Joseph Creeper said I could take this as a warm-up before school starts on June here. Yes, please do. Please do. If Mr. Wick can divide correctly, that would help out. So there we go, guys. At least I caught it in the middle. There you go. It definitely doesn't hurt to start learning about it now. You got it. You got it, Jamila. So that was problem number 28, guys. What's important for this problem to recall is the fact that Tony and Noah went ahead and made a donation. That's one thing to recall on this problem. And that the lateral area for a cone is equivalent to pi times the radius times the slant height. And when solving for that slant height, all we did was replace all the values, the given values, into our formula. And we substituted and then isolated our variable L here, which was representing the slant height, and then we had to divide both sides by 37 pi. And if you can do your long division better than Mr. Witt on the fly, then you would end up with the correct result, which is going to be 2 and 8 tenths centimeters to the first power. There it is. Running away from this problem here, guys. Let's get off of that. Let's go on to something I could probably do better, which is problem number 29. All right, guys. We have to write the ratios for sine of A, cosine of A, and tangent of B. So we have some trigonometry here. We have some trigonometric ratios, guys. There you go. And if you needed to see more examples like problem number 29, then there is a video on Fort Bend Tutoring's website, the YouTube channel rather, where we have a video. All right. Called Finding the 6 Trigonometric Ratios. All right, for trigonometry. There we go. Ken, what's going on Ken? Ken Bueno says, wow, I like that laugh. Yeah, I had to laugh off that long division, Ken. because my long division was sucking this morning, bruh. All right, so let's try to get things better. But I appreciate you got a little value of entertainment out of that, Ken Bueno. So let's check it out, guys. Let's go ahead and look at what these relationships mean. When we're talking about sine of A, the ratio for this is going to be equivalent to the opposite divided by the hypotenuse. You could say that. You could say that it's the y value divided by r. You could say that as well. And one of the tricks that I use as far as finding these trigonometric ratios, guys, is to go ahead and put your finger on the angle that they're referring to. For instance, since they said they wanted us to find sine of A, go ahead and put your finger on A and look straight across from that angle. That is going to be your opposite value. So once again, start on the angle that they're referring to. In this case, they're referring to the angle A for that first question that they have for us. Put your finger on A and then look straight across from that angle, and that'll tell you your opposite angle always. So the opposite side of that, in this case, is going to be 3. Remember that your hypotenuse is always the value that is opposite the 90-degree angle. So in this case, our hypotenuse is the number 5 because that's the longest side of our right triangle, aka the hypotenuse. So therefore, sine of A is 3/5. It is 3/5 is going to be the value for sine. All right. Did you check your work on that, chosen creeper? You should have 3/5 for sine of A. Amen. Amen. Now to check out what we'll need for cosine of A. Well, the relationship, the ratio for cosine of A, guys, is going to be the adjacent side divided by the hypotenuse, or you could say it's going to be that x value over r. So in this case, once again, you're going to put your finger on the angle that you're referring to. So we're looking at A. We already know going straight across is the opposite side. We already know that the longest side opposite the hypotenuse, opposite the right angle rather, is the hypotenuse. So therefore that leftover side is the adjacent side. Yeah, it's the adjacent side. So that means that the adjacent value for our angle A is going to be 4. And it's going to be over divided by the hypotenuse, which is going to be 5 in this case. There you go. So this is our 4/5 value. This is the ratio for cosine of A. Amen, amen. And now let's go ahead and figure out what tan of B is going to be. So the most important thing to remember here, guys, is that they're no longer talking about the angle A, are they? They're now referring to angle B, and they want us to find out the tan of B. Well, the ratio for tan is going to be the opposite divided by the adjacent side. Or you could say it's going to be the y value divided by the x value. Okay, as far as the tan ratio is concerned for the trigonometric ratio, tangent. So where are we at now? We're going to put our finger on B. Put your finger on B. Going straight across from B is going to be the opposite side. That's the way it always works, guys. So that's why I like for you guys to put your finger on the angle that they're referring to. In this case, it's going to be the angle B. You go straight across from there to find out that that opposite side length is going to be 4 in this case. Then we already know that our hypotenuse is 5. That won't change. It always has to be opposite the 90-degree angle. And then that leftover side is going to be the adjacent side. So the adjacent side for angle B is the number 3. So your answer here is going to be 4/3 for tan of B. And there we go. That's right. Chosen Creeper says he needs to watch out for those letters next time. Absolutely. You have to pay attention to which angle you're referring to, Chosen Creeper. Absolutely. Absolutely. So in problem number 29, we had to write the ratios for sine of A, cosine of A, and tan of B. And that meant that you had to make sure that you were anchored at the correct angle. The first two problems for sine and cosine, they were referring to the angle A. So we were anchored up here, up top, for our angle there. And then for that last problem, tan of B, we had to be anchored down here at our angle B. Absolutely, guys. And that is how you find out your trigonometric ratios when you're given a right triangle. That's it. Done and done. That's problem number 29, and we are moving on, son. That is what's up. We're moving on to problem number 30. Yeah, that's what we're doing. We're on number 30 now. Because on the problem number 30, it says the measurement of angle 1 equals 6x. And the measurement of angle 3 is 120. Find the value for x. Find the value of x for P to be parallel to Q. So they're referring to these two lines here. All right. And we have a transversal line going through these lines. They want the lines P and Q to be parallel to one another. There you go. Caleb's in the house. Caleb says that he's glad that I emphasize that the opposite is relative. That's right. That's right. That's why I always say if you guys are having difficulty with those trigonometric ratios, it is most likely because you're not anchoring yourself with the angle that they're referring to. Once you do that, then the easiest thing to find is the opposite side. Notice that even when I needed the adjacent side, I didn't care about finding the adjacent side first because the easiest side in the trigonometric ratio to find is the opposite side because it's always going to be opposite the angle that you're referring to. So anchor yourself at the angle, look straight across from there. The opposite side is always going to be right there on the opposite side of that angle that you're anchored at. And then it makes the rest of it easy because from there you can quickly identify the hypotenuse and that leftover side is going to always be the adjacent side. That's the way you can make sure you're not making mistakes on that, guys. But looking at problem number 30, guys, they want us to find the value of x for which P and Q must be parallel. And so since we're dealing with a transversal, then we know that if it has to be parallel, that our converse attack that we'll be looking at is that corresponding angles are congruent to one another. Same side angles are supplementary. Okay, that alternate interior angles are congruent. All right, only when your lines are parallel. Okay, so what we want to do now, given as though they gave us angle 1 and angle 3 measurements for that in our problem, let's look at the relationship between angle 1 and angle 3. Well, it looks to me, because they're in similar clusters here, and they're located in the upper left corner of those clusters of angles, that they would be corresponding angles. All right, they're definitely corresponding angles, and corresponding angles are congruent to one another when the lines P and Q would be parallel to one another. So that's going to be our setup. We're going to go ahead and show, just as Chosen Creeper has already set up, guys, that 6x, which is the measurement of angle 1, would have to be equivalent to the measurement of angle 3, which is 120 degrees. So in solving for x, all you had to do is just divide both sides by 6, and you'll find that x equals to 20, and that's your answer. Yeah, absolutely. What's going on, Three Musketeers? That's right. Chosen Creeper, you are correct in your setup and for your answer. And that is why we're going to red box it. X has to be 20 in this problem, guys. In order for P and Q to be parallel to one another, that would mean that your corresponding angles 3 and 1 would have to be equivalent to one another. So that's all we had to do was to set up as stating that angle 1 is 6x. And the measurement of angle 3 has to be 120 degrees in order for P and Q to be parallel to one another. So that is the concept behind that. And that's how you go ahead and carry it out and get that answer, just like Chosen Creeper, guys. That's right. And Three Musketeers is in the house, which is my favorite candy bar currently. Thanks, Three Musketeers, for a reminder about that sweet tooth that I may have. Way to go. And I wanted to let you guys know that you can also set up a paid one-on-one online tutorial today with me, Mr. Witt. So anytime you're having difficulty with your mathematics and you're getting stuck and you don't have anybody at the ready to help you out, I will be doing my best to help you out one-on-one in a paid online tutorial, guys. So don't forget to check that out. That information, you can find it at tutormemath.net. The website for Fort Bend Tutoring. Amen, amen. And we got a nice smiley face from Three Musketeers. So let's go ahead and hook up the chat and let's move on to our next problem, which is problem number 31, guys. Problem number 31. Amen, amen. All right. They want us to find the values of X, Y, and Z. And they're reminding us that the diagram is not to scale. That's right, Mr. Witt did not draw this to scale. All right, there you go. So keep that in mind. But what we do know, for starters, as far as angle X is concerned, is that it is part of a smaller triangle here, right? And the sum of the interior angles of a triangle will always add to 180 degrees. So in order to solve for your angle X here, all you need to do is find out the sum of 38 degrees and 56 degrees, and then subtract that from your total sum of the angles, which is 180 degrees. And that's exactly going to be our attack right now. Let's go ahead and do that. So we're going to have the 56 plus the 38. We got 14, carry the 1 there. 1 plus 5 is 6. 6 plus 3 is 9. That's 94. We want to subtract this from 180, guys. All right, so we're going to be borrowing here. We got the 10 minus the 4 is going to give us 6. We got 17 minus the 9 is going to give me 86. So that means that angle X must be 86 degrees. Okay, and notice that angle X and angle Z are linear pairs. They're linear pairs. They must add to 180 degrees. And because they must add to 180 degrees, then if X is 86 degrees, then subtracting 86 from 180 will give us 94. Yeah. We just found out that 180 minus 94 is 86, right? So why not use that value, right? Then within this second smaller triangle, we already given 19 degrees here. We know that angle Z is going to be, oh, I'm sorry, guys, because angle Z is 94 degrees. Let me go ahead and fix this. All right. Once again, that live stream, you got to be on point. You got to be on point, guys. All right. So angle Z we just confirmed was 94 degrees. We already know that angle X is 86 degrees. But now looking for angle Y, we can use the fact that they have given us in the second smaller triangle that one of the angle measurements is 19 degrees. Okay, so what we'll do is we'll add the 94 plus the 19 and subtract that from 180 to get our final result for angle Y. That's what we're doing here. That's what we're doing. We're going to add it together. We got 13 here. That's going to be 113. You're going to be subtracting 113 from 180. That's what you'll do here. Go ahead and borrow. Gotta borrow, guys. Gotta go to the bank. Oh, that's just ugly. Let's fix it. There we go. So 10 minus the 3 gives us 7 here. Absolutely. We have 7 minus the 1 that gives me 6. And so we end up with 67 degrees as a result. Ladies and gentlemen, for problem number 31, we have our 3 angles solved for. Yes, we do. And Chosen Creeper, you got all 3 correct. Thank you. Let's go ahead and red box these answers. Red boxing it. Because Simone, she stays on top of me, guys. All right, Simone, she has to make sure that I red box my answers. She catches me slipping when I don't do that. So we got to red box it. And that was problem number 31. On problem number 32, guys. Problem number 32. We have 2 triangles that are congruent. Find the value of C, D, E, and F. That's exactly what they want us to do. Well, when you're dealing with 2 triangles that are congruent, guys, you should know that all the angle measurements in both triangles are they're congruent. They're the same measurement, respectively. Okay, so all the angles are the same, and all the side lengths are the same. So when you're dealing with congruent triangles, you need to know that all the angle measurements are identical to one another, as well as their side lengths. Now, if we were dealing with similar triangles, all the angles would be the same, but the side lengths would be proportional. So if you're confused between congruent shapes and similar shapes, that's the difference. Let me go ahead and outline that again for you. That congruent shapes have the exact same angle measurements with the exact same side lengths, whereas similar shapes have the exact same angle measurements, but their side lengths may not be identical, but they will be proportional. And that is the difference between similar shapes and congruent shapes. So we're on a one-to-one basis right here. Yeah, in other words, when I'm looking at the value of C, notice that the value of C is at the bottom, at the base of our triangle here. So that value for our base in this other triangle must be equivalent to C. So in other words, C is 3. That's the bottom line. But it has to be the same value. So D is an angle measurement. Well, that's in the upper area of our triangle. So that measurement in the other triangle is 38 degrees. So that means that D has to be 38 degrees. You see what I'm saying? So everything that corresponds to one another is going to be equivalent to one another. Yeah. So your corresponding side measurements are equivalent to each other. And that's right, Simone. These triangles are twins. Identical twins, Simone. That's a very good way to say that. Always coming in with a good lingo, Simone. What's going on? Obina. Obina's in the house. Obina's in the house. How you doing, Obina? What's going on there? And Obina says that E must be 90 degrees. That's correct, because they're showing us with this symbol here that we're dealing with a right angle in that spot, and every right angle is 90 degrees. So since E is in the same location as our right angle symbol, it has to be 90 degrees. Good job, Obina. Always in the house there. And Obina goes on to say that she knows that the value of F must be 52 degrees because it's in the same location. And that is the way you can determine the angle measurements and side measurements of congruent triangles. Just like that. Great job, Obina. And crew. All right. Because Chosen Creeper was helping out too. Good deal. As well as Simone. That's right. Letting us know that these two triangles must be twins, which means we are ready to red box our answers. That's right, guys. Good problem. That was problem number 32. Problem number 32. Done. Done. Great job, guys. You did awesome on that. Let's go ahead and look at our next problem here, which we have problem number 33. And in 33, it says, can you use the ASA postulate, which stands for angle side angle? The AAS theorem, no, it's not what you're thinking. It's angle side theorem, thank you, or both, to prove the triangles are congruent to one another. And here are our answer choices. Either angle side angle or angle side. B, angle side angle only. C, angle side only. Or D, neither. Let's see. Well, what I want to do, guys, is I want to go ahead and state what I know to be true about our diagram. Because what I'm looking at here, guys, is I'm looking at two triangles, all right, that is sharing a vertex here. And also I'm looking at two line segments that are intersecting, correct? And anytime you have two line segments that are intersecting, their opposing angles that are created are going to be congruent because these are called vertical angles. So that means that this angle measurement has to be congruent with this angle measurement here. So as I look at each triangle, starting at the vertex that is shared here, then I can say that I have an angle, and then a congruent side with the other triangle. So this is angle side. Now it cannot be angle side angle because this captured side would have to be between the angles that are congruent to one another, and it's not. So this is not a situation where we can use angle side angle. This is clearly angle side. In the other triangle, you have angle side. You don't have an angle, then a side that's congruent to the other triangle, and then an angle that follows it. No, you don't. Consecutively, you have angle side only, and that is why our answer must be C. It's got to be C, guys. It's angle side only for this problem right here. It would not be either angle side angle or angle side. It definitely wouldn't be angle side angle only. It's going to be angle side, because when you're proving this, the angle measurements have to be consecutive, and then it has to be followed up by it has to be followed up by the congruent side measurement. Chosen Creeper says, thank you for reminding him. My pleasure, Chosen Creeper. That is the point of these final exam reviews, is to refresh your memory. Even if you're not currently taking the class, you want to be reminded about all of these properties, because that's one of the most difficult things about geometry, guys, is that you have so many formulas, so many properties to keep in mind when you're solving these problems in geometry. So I'm here to refresh your memories, and for those of you that need to take the final exam soon, that you will be better prepared by participating in today's final exam review. All right, and don't worry, guys, if you missed part of this already, don't worry, it'll be posted on the YouTube channel for Ben Tutoring shortly after we're done today. All right, so it will be on the YouTube channel for your viewing pleasure in a short while after it completes processing. Problem number 34. Problem number 34. It says to find the length of the midsegment. Once again, the diagram is not to scale. So what we're looking at, guys, is we're looking at a triangle, obviously, all right, a larger triangle, and we're looking at two parallel line segments that in itself would create a smaller triangle within this, right? Okay, and we're going to keep in mind, guys, the triangle mid-segment theorem. Once again, what Chosen Creeper is talking about, getting a reminder of all of these rules in geometry. Well, one of those rules is the triangle mid-segments theorem, and it states that if you have two parallel line segments within a triangle, that parallel line segment must be the mid-segment. It would be the mid-segment, and the way it works is that mid-segment is going to be half of that base. Is going to be half the length of the base. So that means that 4x plus 2, if we were to set this up as an equation, that 4x plus 2 would be equivalent to half of our base here. Half of the 4x plus 44 is what we'll be dealing with. And that's the way you set it up for solving for x for our midsegment here, okay? So it says they want us to find the length of that. What's going on, Danny? So we can find out the value of x, and then we'll need to plug that in because they want us to find the length of the midsegment. So it's just not going to be good enough to solve for x. We'll also want to actually find the length of the midsegment. In this case, our midsegment is the segment DE, guys. It is the segment DE. So let's go ahead and solve for this. So I'm going to get my arrows popping, guys, because I get to use the distributive property, my favorite property in the world. That's right. And we'll end up with 4x plus 2. This is equals to 2x, taking half of 4x, plus 22. I will then subtract 2x to both sides. I'm going to go ahead and squeeze in 2 steps on this one, guys. Subtracting 2 to both sides here. Yep, just like that. And I'll end up with 2x being equivalent to 22 minus 2 is going to be 20, right? Then we'll divide both sides by 2 to get x equals to 10. However, the result of 10 for x is not our answer, guys. They didn't say to solve for x. They said to find out the length of the midsegment. All right. So remember that DE is our midsegment here, and we'll have 4 times x, which in this case is 10, plus 2 to find out that 40 plus 2, which is 42, is going to be the length of our midsegment, and we will have that unit to the first power. So it'll be 42 units, whatever that unit may be, whether it be inches or centimeters or what have you, because we're dealing with the distance of a length of a segment in a triangle. It'll be to the first power. So Obina has it correct with 42 is the length of DE. And this is how we utilize the triangle midsegment theorem, guys. Notice that the midsegment, once again, must be parallel to the base of the triangle. There you go. There you go. And Obina says, shoot, she forgot her units. Don't forget the units, Obina. That's right. You got to have those units in mind when you're dealing with applications, when you're dealing with geometry. You got to have the units in play. You want to know, you want to state, you want to show off that you know that when you're dealing with the length of a line segment, that the unit of measurement will be to the first power. So it's going to be 42 units to the first power. Done and done, guys. That's what's up with problem number 34. That was a good problem, right? I got some good problems for you guys today. I'm excited about them, and that's saying a lot because I generally don't care for geometry that much, but I am excited about today's problems that I have for you guys. All right, it should definitely prepare you for any final exam that you have for geometry. So here we have problem number 35. It says that ray, all right, because that's a ray, but they will go ahead and say that the segment DF bisects the angle EDG. They want us to find the value of x. There are several ways to go about solving this problem, guys, but what I'm going to be using for this one, all right, is I'm going to be using CPCTC, which stands for congruent parts of congruent triangles are congruent. Simone says the top portion looks like a right triangle while the bottom portion looks like a trapezoid. Ah, interesting. Okay. So you treat it like two separates. Are you talking about so do we treat it like two separates? Well, it wouldn't be qualified as a trapezoid, the bottom portion altogether, because for it to be a trapezoid, you would have to have two parallel sides of that four-sided figure. So that wouldn't qualify for it. So let me show you what we will do. All right, let's do that. For starters, guys, we can prove that these are going to be two congruent triangles by the fact that they're sharing a side. The smaller triangles within the two right triangles that you find between these two angles here, they're going to be proven to be congruent by the, let's see here. Let's use, got it. We're going to be using the angle side property. That's right. We're going to be using the angle side theorem to prove that these two triangles within the angle here is going to be congruent. How do I know that? Because I'm looking at a 90-degree angle. I'm looking at a shared 30-degree angle. Notice, guys, that they have this symbol here to show that this smaller triangle, this smaller angle here is 30 degrees, but it's also 30 degrees here within this triangle. So we're looking at a 90-degree angle, we're looking at a 30-degree angle, and it is obvious, guys, that they are sharing the same segment of DF. So that means that they have that segment in common together. So we're looking at the angle side postulate, the angle side theorem. I think it's a theorem. The angle side theorem to prove that these two triangles within are congruent to one another. And as I stated before, we can use the congruent parts of congruent triangles is congruent formula, well, postulate theorem. If I can get it together, we can say that it's CPCTC, that congruent parts of congruent triangles are congruent, meaning that these segments must be equivalent to one another. So the first thing is to prove that the triangles are congruent to each other. All right, Simone, I'll take a look at that in just a second. So what we'll do is we'll solve for x, because we know that these segments must be congruent to one another. They must be equal to one another. So that means that 8x plus 42 has to be equivalent to 15x. And then we'll subtract 8x to both sides. And that tells us that we have 42, which equals to 7x. And then dividing both sides by 7, we'll find that x equals 6, guys. X equals 6. And that's it. So how do we attack the problem? We attack the problem by, first of all, proving that the two triangles, all right, within the larger angle, EDG, were congruent to one another. And we used the fact that we knew that we had the angle side theorem that told us, that proved that those two triangles were congruent to one another. And as we stated before, when you're dealing with congruent triangles, that all of their parts, including their angles, must be congruent to one another. Obina has the right answer. Three Musketeers has the right answer. And Chosen Creeper says, I read his mind. That's right, because you also have the correct answer, Chosen Creeper. That's right, guys. So that's the way we tackle that problem. Once again, an excellent problem. That's right. Obina says, I knew they were congruent to start. Good job, Obina. Good job. But remember, it's not only enough to know that they are congruent. You have to be able to prove that they are congruent in geometry. A lot of geometry is all about those proofs, guys. So you have to have it to back it up, just like Angry Hermit is in the house, backing it up. What's going on, Angry Hermit? That's right. So let's look at that previous problem that you were talking about, Simone. So Simone's, got you. You're right, Simone. That is a triangle. You got a trapezoid down below. You also have a larger triangle. But we're using the fact that this mid segment here, that this line segment here, that is parallel to our base, is also called the mid segment in order to solve this. All right, so that's the rules that we're using for this. It's not the fact that we're dealing with a triangle and a trapezoid that helped us solve this problem. It was the fact that we realized that in order for this segment here to be parallel to the base, that you had to be dealing with you had to be dealing with in fact a midsegment, because for one, they told us that it was a midsegment. All right, so they told us that we were dealing with our midsegment, and the relationship between the midsegment and the base is that the base is twice as long as our midsegment there. All right. Also notice that we had to be able to show that these two lines here that we're dealing with the medians. All right, the middle points of these segments here is where our line segment was connected. See, those were congruent. 47, 47. That's 56. That's 56. So the line that connects the midpoints of the opposite sides here in a triangle is how you're going to be able to form the midsegment. And the midsegment's length is always going to be half the length of the base, and the midsegment will be parallel to the base. There you go. Yeah, I think that was proper now. There you go. I had to get my words together on the fly, guys. We're on problem number 36, though. What's up with that? Problem number 36. Let's check this out. With problem number 36, guys, we have the following. Angry Hermit is in the house. It says to find the value of x, if necessary, round to the nearest tenth. Well, clearly, guys, we have a circle here, right? We have two triangles within, right? And what I'm going to do, first thing I'm going to do is I'm going to realize, guys, that if P is the center of the circle, that segment DP, CP, BP, AP, those are all radii. Yeah, each one of those is the radius. And if each one of those is the radius, that means that this segment has to be congruent to that segment, and that this segment has to be congruent to that segment, because they're all going to be from the center to a point on the circle. They're going to be radius. They're going to be, all of those segments are radii. So they're all the same length. And because they're all the same length, guys, notice that we are now looking at congruent triangles based on the side postulate. There you go. So if all the side lengths of two triangles are equal to one another, then you are dealing with congruent triangles. And since I'm dealing with congruent triangles, we can now utilize CPCTC. Once again, that congruent parts of congruent triangles must be congruent. And if this angle measurement is 77 degrees, then our value for x must also be 77 degrees. And that's the answer. That's right, Three Musketeers, CPCTC. And you can prove that using the side postulate, because all three segments of our triangles had the same length. So that's how we can prove that those two triangles were congruent to one another. So therefore, as Three Musketeers has pointed out, our measurement for x is 77 degrees. There you go. So that's what I was talking about earlier, Obina, that it's not just enough to know that you're dealing with congruent triangles. You have to also be able to prove it. That's right. So Chosen Creeper says that feel when the answer is there all along. That's right. It's right there in your face. And you know what, Chosen Creeper? They're trying to throw you off in this problem, because look at them talking about if necessary round to the nearest tenth. So they're already stressing you out, thinking that you have to do a lot of mathematical computations and stuff to get the answer. Wrong. You don't have to do none of that crap. All you gotta do is just realize that you're dealing with congruent triangles and be like, oh, okay, if that's 77, then that has to be 77, and done. And you're so red boxing it and moving on to the next problem, which is why it's important, guys, to keep in mind the difference between knowing and not knowing. Look how easy that was once we knew how to attack the problem. All right, I know that there would have been a point in my life when I would have been trying to think about some type of calculations, worry about the circle, worry about 360 degrees and all, how that all plays into this problem, stressing myself out. when all we had to do was realize that we're dealing with congruent triangles and just say, oh, okay, if that's 77 degrees, then that has to be 77 degrees. So that's why it's so important to be aware of many of the properties, postulates, and theorems that you'll find in geometry, because they can actually assist you in your efficiency doing a test. All right, you don't have to take all day on this problem if you are aware of those things. So that's what I'm here to do. I'm here to remind you of all those things that your teacher exposed you to this semester and throughout the year in geometry. Guys, just want to remind you guys to subscribe to the YouTube channel, Fort Bend Tutoring. Click on that subscribe button right there. Also, right next to it is a bell icon that'll help you know when we are live with new content, whether it be a live stream or I'm just uploading a studio video. That's right. Something that I took some time to curate, make sure I didn't make any mistakes in it, as I've been doing on these past live videos, guys. Been making some mistakes here and there, guys. That's why I need you to make sure I'm making the right moves on these problems here in the live streams. So please share the stream with the people that you know and you love. Subscribe on the YouTube video. Also, like the video. You know, it helps out. It really does. Let's move on to our next problem, guys. We have problem number 37. Problem number 37 is in the house. That's right. Let's go ahead and see what the chat's looking like. There we go. That's right. Just let you guys know that you're in the house. Three Musketeers, Angry Hermit, Simone, Chosen Creeper. There you guys are. You're right there with me. Find the measure of angle BAC. Find the measure of angle BAC. Well, they're already telling us that angle BOC is 57 degrees, right? And because AC is what's it called? Oh, it's called the diameter. That's exactly what it's called. AC is a diameter, guys. That's going to be a linear pair. So it's supplemental. That this angle right here will be supplementary to that angle there. In other words, we can figure it out by subtracting from 180. Let's do that. So we have 180 minus 57 degrees. That's going to be 7. That's going to be a 10. That's going to be a 3. That's going to be a 2. So we end up with 123 degrees for our angle measurement right there. And what you need to know, guys, is that we are dealing with an isosceles triangle. How can I prove this? Because the lengths from A to O and from O to B are radii. They're the radius of the circle, so they must be the same value. So we've already proven that what we're dealing with this triangle within the circle is that we have an isosceles triangle. And when you have an isosceles triangle, your base angles must be congruent to one another. They must be congruent to one another. And why would I want to find out the measurement of these base angles? Well, because they want us to find the measurement of angle BAC. That's why. So what you can do from here is you can start out by realizing that, oh, okay, if this angle, the vertex angle, if that's 123 degrees, then the sum of A and B must be 57 degrees. So we can say that 2x, let's go ahead and change my ink here. You know I like to write in black. That we have 2x is equivalent to 57, and then we will solve for x. That's right. So definitely, Chosen Creeper, all radii are congruent. Absolutely. Absolutely keep that in mind, because that will come in handy. Notice how we used that in the previous problem as well. So that means that we're going to be taking half of 57 in order to find out our answer, guys. And I got to try to make up for that other problem. I think it was the second problem where I couldn't divide. Let's go ahead and see if I can make up for that today. We'll have 2 going into 5 twice. It's going to be 4. We'll change the sign. We'll have a 1 to 7. 2 goes into 17. That's going to be 8 times. We'll have 16. We'll bring down the 1 to 0. 2 goes into 10 5 times. There we go. 28 5/10 degrees is going to be the measurement of each of our base angles in our isosceles triangle, guys. So therefore, we have our result for angle BAC, that it will be 28 5/10 degrees. And just to let you guys know, Obina had that answer a long time ago. Way to go, Obina. Way to go. So that was another problem. And also, guys, notice how I take my time and I define as much as I can in the diagram that I have in the problem. All right. Notice that I don't always just rush to do any type of algebra or mathematics within the problem, that I analyze the diagram first, and I try to set myself up with as much information as I possibly can before I move forward. All right, good job, Tony and Noah. 28 and 5/10 degrees is the answer. Good job. Great job. And that's what we have for problem number 37, guys. That was another great problem. Once again, I am patting myself on the back for bringing you guys some great problems to work on today. That's right. Let's look at problem number 38, guys, as we do some trigonometry again. That's right. Dealing with some trig ratios. It says to find x for all x's between the angle measurements 0 and 360 degrees exactly without a calculator. Obina says, I actually realize everything about the triangle I need to know just by looking at it. I know what you're going to say. I get it. That is fantastic, Obina. I think Obina is referring to the fact that she knows that I'm going to say that you have to be able to prove it too. Is that right, Obina? Is that what you were talking about? You know what I'm going to say? That's right, because it's not just good enough for you to know it. You have to be able to prove it to somebody else. All right? So that's what math is all about, proving yourself. Good stuff. And documentation, you got to document it. All right, so with problem number 38, we're dealing with a trig problem. They're confining us to 360 degrees if we're looking at this within a circle. But since we're also looking at it in a rectangular coordinate system, guys, you need to know that sine is a positive answer. That's important because sine is positive only in the first and the second quadrants. So if you're looking at the different quadrants here, we have the first quadrant, we have the second quadrant here, we have the third quadrant, we have the fourth quadrant, and sine is going to be a positive value only in the first and the second quadrants. That's what's up. And Obina says that she knows that the answer is 30 degrees. She has the unit circle with me. But you also need to keep in mind, guys, that they have given us some boundaries as far as the answer is concerned. They said to find all x's where x would be between 0 degrees and 360 degrees. So you need to know that sine is positive in the first and the second quadrant, meaning that you can find this answer in both the first and second quadrants of the rectangular coordinate system. So this is what I'm going to show you guys. What I do is I like to use right triangles to help me out here. I know that the ratio for sine, guys, as I talked about before, is equivalent to y over r. So in solving for this, we have 1 for y, the opposite value. Remember, it's going to be the opposite over the hypotenuse. I gave you that ratio earlier. So if 1 is our opposite value from our angle theta here that we're trying to solve for in the first quadrant, that our hypotenuse would be 2. And this relationship, guys, if you use the Pythagorean theorem, you'll end up with the square root of 3 right here. This will be the square root of 3. So this relationship, if you recall from our first part of the Geometry Final Exam Review, this is the ratio. This is the relationship when you're dealing with a 30, 60, 90 triangle. A 30, 60, 90 triangle, where if you know that your value of x is for 30 degrees, that the 60 degree angle, the side opposite of that would be x times the square root of 3, and that the side opposite the 90 degree angle would be 2 times that value of the 30 degree side. Or simplified, it would be 1 square root of 3 and 2 as far as the ratios are concerned. So using special triangles, all right, using special triangles, we can go ahead and identify what this is. Ruby says, hi, do you have a pre-algebra final exam review? Absolutely. Look at the final exam review that is called Foundations of Mathematics. Look at the final exam review that's called Foundations of Mathematics. And if you need a foundation prior to that one, look at the final exam review that says Basic Mathematics in our final exam review playlist, Rudy. All right. So that should answer that question for you. All right. No problem, Rudy. So those 2 final exam reviews, check out the one that says Foundations of Mathematics first. And then if that's too advanced, then go down to the one that says Basic Mathematics. All right. Take care, Rudy. All right, now, guys, we can confirm that since we're talking about sine, and sine has to be 1/2, that the angle measurement that they're referring to has to be 30 degrees. And notice that this is going to be x. So we should identify this as x instead of theta. So this would be x in here. Okay. See if I can fix that without tearing it up. Better. So this is x degrees in here. Yep. X degrees. We'll just leave that as an x, guys. That's from the first quadrant. So Obina, I agree that your 30 degrees is correct. But what I won't agree with is that that's a complete answer, because they're taking us all around the circle, guys. What's going on, Swag Wave? Welcome back. And we just confirmed, I just told you guys, that sine is also positive in the second quadrant. So we can make an identical right triangle in the second quadrant where we're solving for x, where the y value, the x, the opposite value of that angle has to be 1, our hypotenuse is 2, and we would end up with a negative square root of 3 for our value of x here. Well, 30 degrees, remember, is opposite that 1. So 30 degrees off of the 180 degrees. Remember that this is 0 degrees. Is a circle. This would be 90 degrees. This would be 180 degrees. And this would be 270 degrees. And we would also come back here for 360 degrees here. So if you're looking at the rectangular coordinate system as a circle, this is where the angle measurements will line up. That's right. All right, I'll think about that, Swag Wave, as far as those games are concerned. Thank you, because I do like to play video games. Can't wait for Destiny 2 to come out. I like Destiny. And Fallout 3 or 4. Fallout 4. That was the last one that came out. So 30 degrees off of the 180 degrees gives us also the angle measurement 150 degrees. So your answer for this is 30 degrees and 150 degrees, Obina, because we had to find all of the angle measurements where we would end up with 1/2 as a result. What's going on, Obina? That's right. We had to find out all the angle measurements that occurred where sine would be 1/2 within 0 degrees to 360 degrees. So yes, it happens at the 30 degree mark, but go ahead. That's right. And also, here you're going to be in the 150 degrees as well. That's right. Done and done. What do you mean you're spamming the thing? You're not spamming anything, Obina. What are you talking about? That's problem number 38, guys. That's problem number 38. So because they gave us the boundaries going from 0 to 360 degrees, that is going to be multiple answers where sine is equivalent to 1/2. The first thing we identified is the quadrants where sine would be 1/2, where it would be positive. That would occur in the first quadrant and the second quadrant. So knowing that, I knew from the beginning I would end up with 2 answers because of that. Absolutely, Obina. The 30, 60, 90 triangle definitely helps out. Absolutely. All right. That's problem number 38, guys. We have a similar problem for you with problem number 39. Yes, ma'am. I understand that, Obina. That is the downside to using the unit circle without analyzing the problem first. You had to know where to look on the unit circle. So that was my point, that you wanted to know from the beginning that there was going to be 2 areas of the unit circle where you could find sine being a positive 1/2. Absolutely. So let's check out how we can use that same process to solve for problem number 39. We have find x where x is going to be greater than or equal to 0 as well as less than or equal to 360 degrees. We want to find out the exact measurement without using a calculator. So we're looking at cosine, guys. So when you're looking at the rectangular coordinate system, when you're dealing with trigonometric values, you need to know for every ordered pair that the x value is the cosine of x, whereas the y value is going to be the sine of x. And that's why I can confidently say that in the first quadrant, cosine is positive. In the second quadrant, cosine is negative. In the third quadrant, cosine is negative. And in the fourth quadrant, sine is going to be cosine is going to be positive. How am I doing this? Because I know that in the first quadrant, all of my ordered pairs are positive, positive. The ordered pairs in the second quadrant are going to be negative, positive. In the third quadrant, the ordered pairs are going to be negative, negative. And in the fourth quadrant, the ordered pairs are positive, negative. And if I already stated that the cosine value is going to be where your x value is in the ordered pair, this is how I'm able to determine that cosine being a negative value will occur in the second quadrant as well as in the third quadrant, because this is where we have highlighted the fact that our x values are negative. Our x values are negative in the second, and the third quadrant. All right, Swagwave says, all right, you're going to be back in a little bit, Mr. Witt, I understand. Cool. Good job. Raul has the answer, 135 degrees and 225 degrees. All right, we shall see. I also noticed that you never have dislikes. That's a sign of savageness. Appreciate that, Swagwave. I'm trying to keep those dislikes down and the likes up. So if you would, guys, go ahead and give this video a like. I would greatly appreciate it. That is right. So knowing that we're going to be starting, Obina, in the second and the third quadrant based on the fact that cosine is negative and we have the full range of the circle in play because of our values of x. All right. What? A dislike chose a creeper already? All right. Well, I guess it happens, bro. I guess it happens. Too funny. Good stuff. All right, Tony, you take care. Noah, you take care. Appreciate the donation today, guys. Thanks so much. Good job. All right, so let's go ahead and figure this problem out, guys. It's all good. We're going to be doing the following. We're going to be in the second quadrant with a right triangle. We'll be in the third quadrant with a right triangle. But let's do the second quadrant first, guys. So this is going to be our value of x. This is where my angle is going to be. All right, and let's go ahead and fix that triangle. It's ugly, guys. Ugly triangle right here. Let's fix it. I want to show that my triangle is looking kind of cute. That's much. Oh, almost. I was bragging too soon. There we go. There we go. That's better. And let's say this angle is x. Because cosine, guys, has a ratio of the adjacent side divided by the hypotenuse, or you can say x over r, then that means that in this ratio where negative square root of 2 divided by 2 is concerned, you would have negative square root of 2 here. You know what? Do I want to? Yeah, I think I want to simplify this, guys. Yeah, I think I want to simplify this. Yeah, I want to. Let's take this this negative square root of 2 over 2, guys. Let's put it back the way it was. What I mean by that, if you multiply this back as square root of 2 over square root of 2, you would end up with a negative 2 over 2 times the square root of 2, and you would end up reducing this to negative 1 over the square root of 2. Yeah. That's what's up. All right. All right, swag wave, no problem. The dislike is gone. That's funny. You guys are going crazy over there. It's all right. Let people have their opinion. It is what it is. So what I wanted to show you guys so that you be aware of this is that if you rationalize the numerator and the denominator, we rationalize the numerator rather, in this case, you would end up knowing that the x value is negative 1, okay? Whereas the hypotenuse here is going to be square root of 2, which means that your y value using the Pythagorean theorem will give you a positive 1. All right, and this is how we can show this. Because we have a 1 square root of 2 ratio, this is going to be equivalent to the special triangle that is a 45, 45, 90 triangle. And that 45, 45, 90 triangle, guys, has a ratio. Let's go ahead and move this down, guys, so I can show you guys this ratio for a 45, 45, 90 triangle. It has a ratio of 1, 1 square root of 2. So once we saw that we had the 1, 1 square root of 2 going into play, I knew that we were dealing with a 45, 45, 90 triangle. So therefore, I need to be 45 degrees off of the 180 degrees from here. That's going to give me 135 degrees for this first value of x. So x equals 135 degrees for this first angle that will give us a result of negative square root of 2 over 2 for cosine. Simone, who's having technical difficulties? Is it me? Or were you talking about that you had technical difficulties? All right. So that's the first angle. There's going to be another angle. We know that angle will occur in the third quadrant because we just showed earlier that since the sines of cosine, the value of cosine will be negative in the second and the third quadrant, that means that there will be another angle measurement where we can get this. All right. Jamila asks, Mr. Witt, do you teach calculus too? Yes. And there is a playlist for calculus. In my next studio video, Jamila is going to be over a calculus concept. Let's go ahead and check out a right triangle that would be set up here, guys. Excuse me. We would have the x value being -1. Y value is -1. Hypotenuse would be the square root of 2. So this confirms that we would also be 45 degrees off of the 180, but in a positive manner. So you add 45 degrees to 180 to get your other angle measurement of 225 degrees. So as far as the solution set is for problem number 39, guys, we're looking at both answers. We're looking at 135 degrees as well as 225 degrees. And we used our special triangle, the 45, 45, 90 degree triangles, to assist us in that process because of the ratios that were clear to us. That 1 square root of 2 ratio confirmed that we were dealing with a 45, 45, 90 triangle, guys. So you could use the unit circle to assist you, but I never memorized the unit circle, guys. I always use right triangles to do it. I just generate them each time. Yep, never memorized the unit circle. So if you do have that unit circle memorized, good for you. But that's just not something I ever chose to do. I just generate them. That's right. All right, there we go, guys. We have the answers for problem number 39. Obina says 45 degrees off the right angle. Yeah, that's right. 45 degrees off of the 180 degrees where we were at. That's right. So we were using these reference angles here. The 180 degrees there. We were making sure that we were aware of our location on the rectangular coordinate system. And we knew that we were 45 degrees off of the 180. And that's how we knew that we were at 135 degrees as well as the 225 degrees, Obina. Done and done. So it would have been correctly, Obina, it would have been 180 minus 45 to get the 135 degrees here. And it would be 180 plus 45 degrees to get you to 225. That's what you're looking at. That's what you're looking at. All right. Let's move on, guys. Problem number 40 is in play. And in problem number 40, we're dealing with the line y equals 5x plus 2y. So let's go ahead and fix this because this is not correct. All right. 5y plus 2y. This is supposed to equal to 30. All right. Let me fix this ink. Good thing I remember this problem. There you go, because it was not complete. There we go. This is what the problem is supposed to be. Good, because I have to take calculus class after I finish algebra with trigonometry class. You got it, Jamila. I'll be ready for you. I'll be ready to help you with your calculus. All right, good deal. So here we'll have problem number 40, guys. It says find the x and y intercepts of the line 5x plus 2y equals 30. Well, the process for finding the x-intercept, guys, is as follows. The x-intercept, all you got to do is plug in 0 for y and solve for x. So you can go about the process of saying that you have 5x plus 2 times 0 equals 30. This gives you 5x equals 30. And then solving for x, you'll get 6. So your x-intercept as an ordered pair would be 6, 0. That's the x-intercept of the linear equation that was given to us. Next up, we will be looking at the y-intercept. The y-intercept is going to be the opposite process. Obina has our answer already. So the y-intercept, you're going to be plugging in 0 for x and solving for y. So for the y-intercept of this line, you'll rewrite the equation as 5 times 0 plus 2y equals 30, which is equivalent to 2y equals to 30, and then you'll just divide both sides by 2, and so you'll end up with y equaling to 15. So as an ordered pair, your y-intercept is going to be 15, 0. No. 0, 15. Thank you. Had to check myself there. There we go. There you go. So you end up with 6, 0, and 0, 15. So most of the time when you're given these x-intercept and y-intercept problems, guys, you need to be prepared to present your answer as an ordered pair, as you would find it on the rectangular coordinate system. All right. And depending on the author, they may just go ahead and just say that it's 6 or 15. But most of the time, they'll want you to write it as an ordered pair. So it's always good to know how it is written in that manner. So remember that when you're dealing with an ordered pair, that the first value is the x value, the second value is the y value in an ordered pair scenario there. And then as far as the x-intercept is concerned, we plugged in 0 for y. All right, and solve for x. So we already know that our y value must be 0 when we're dealing with the x-intercept. Likewise, with the y-intercept, we plugged in 0 for x. So therefore, that's why in the ordered pair, we have a 0 value for the x there. That's what's up. What's going on, Sim? All right. How you doing there? Thank you for joining us today. All right, so that's problem number 40, guys. That was problem number 40. And Sim is saying hello. Say hello to Sim. All right. Here we have problem number 41 in play, guys. What do y'all think about that diagram? Pretty good, huh? I spent like 5 hours making that. It took me forever. Thank you. But that's what's going on. Yeah. That's what the deal is. All right. So we have problem number 41. And with problem number 41, it says to find the area of the sector. The area of the sector. And I've even provided a formula here. There you go. Aren't that nice? So with this in play, we have to find the area of the sector of a circle, guys. All right. Simone being nice, saying hello to Sim. Thank you, Simone. And we're going to solve for this area by plugging in the amount of our central angle here, which is going to be 60 degrees. So we'll say 60 divided by 360 degrees times the area of the circle, which can be found by multiplying pi times the radius squared. And our radius is 4 in this case. All right. Good stuff. Chosen Creeper says that blue triangle looks like it's floating. That was the whole point, Chosen Creeper, just to show you guys that I had some skills around here. All right. Not bad, huh? You like that? Good stuff. So I was trying to step up my diagram game, guys. All right. But it took me forever to do it. All right. And it's still not perfect, but it does give the effect. All right. Good stuff. Thanks, Simone. Just wanted to showcase my skills there every once in a while. Obina has an answer, guys. So let's check this out. 60 goes into itself once. 60 goes into 366 times. We know that 4 squared is 16, so you're going to be multiplying 1/6. You'll be multiplying 1/6 times 16 pi. All right. Simplifying this, we'll have 16 pi divided by 6, which we can reduce to 8 pi over 3. And so you'll end up with 8 pi over 3 units squared. So it's going to be centimeters squared. There we go. You got to simplify it. That's right. Got to simplify it. So Obina says she forgot to simplify. It's going to be 8 pi divided by 3. Absolutely. Angry Herman says, do I like to draw? Sometimes, yeah. Sometimes. I don't do it regularly, though. Chosen Creeper, what's wrong with your answer? You have 8/3. I have 8/3 as well, but we had the value of pi in there, remember? Did you remember your value of pi? Because you have 8/3, Chosen Creeper. All right. Your answer is not the same because you're missing pi in there. You have to have that value of pi in there as well. That's what you're missing. Jamila says 3D triangles. It's not a triangle. It's supposed to be a part of a circle, guys. That's what it's supposed to be. It's not a triangle. All right. It's a sector. It's like this. All right. See, now y'all got me second guessing my art skills here. Yes, that would be the same, Chosen Creeper. 8 pi divided by 3 is equivalent to 8/3 times pi. All right, so you could write your answer that way as well. So this is what we're looking at as far as the area of the sector is concerned. And now I'm about to show you guys that I can't draw because y'all making me do this on the fly now. But basically, this is what we're supposed to be looking at here, okay? So they're asking us to find out this area in here, all right? That's what we're doing. We're trying to find the area of the sector. So what we're seeing here is just a piece of this circle and finding out what that area is. So this problem could have been done with this diagram. Of course, it's not as cute, by showing that this is 60 degrees and that you had a radius of 4 centimeters. So basically, you could see this problem written this way as just a sector as you see it, or it could be shown as part of the circle that it came from. That's right. Pac-Man in the house. Piece of cake. Exactly. All right. No problem, Jamila. You just hurt my feelings a little bit. It's all good. But I still think my diagram is pretty boss. Just saying, especially since I freehanded. All right. That was freehand. You know what I'm saying? That was freehand. 41 is in the 41 is done, guys. Do we have a red box around that answer? No, we didn't. Let's go ahead and put a red box around that before Simone chews me out for not putting a red box around my answers like always. So we have 8 pi divided by 3 centimeters squared, and we red boxed it. That's exactly what we did. That was a good problem, guys. I love my diagram on this one, all right? So thank you guys for pointing out that it looked like it was floating, because that was the whole idea. Spent forever on that problem. All right. So here we have problem number 42. With problem number 42, it says find the missing segment. Find the missing segments. And when you have intersecting lines within a circle, you'll end up with a problem like this. All right. Good stuff. Simone says she was hoping that I noticed that I had the red box before she said something. But keep me on point, Simone. I need you guys. All right. So notice that we have these intersecting line segments within the circle. Okay. There is something called the chord-chord product theorem. It's right here. That's right. I made myself some notes in case I messed up. That the product of each of the pieces of these line segments here, if they are to be multiplied together, all right, then they must be equivalent to the other product from the other line segments. Yeah. Jamila says, yeah, it does remind me of Pac-Man, Miss Pac-Man. Good deal. Talking about that previous problem. So here, what we need to keep in mind, guys, is that they've made notations on our diagram to inform us that these two segments are the same length. So if this segment's length is x, then that means that this segment must also be x as well. So according to our chord-chord product theorem, that we can multiply x times x, and that should be equivalent to 4 times 8. So in multiplying this out, you'll have x squared equals to 32, and then to solve for x, you'll be taking the square root of both sides of the equal sign. Remember, when you're dealing with these segments within geometric problems, that you're definitely looking for the principal root here. All right, so you don't have to be worried about a negative root, because in geometry, all of your segment lengths will be positive. All right, so therefore, we're going to simplify this even further, knowing that our largest perfect square within 32 is 16. So I can expand that to show that 32 is the product of 16 times 2, knowing that 16 is the largest perfect square within 32. And then finding out my positive roots simplified, I'll have x being equal to 4 times the square root of 2. And this is the length of the segment that I have here. And this would be 4 times the square root of 2 units to the first power. And there we have our answer for problem number 42, guys. That's right. So we end up with 4 times the square root of 2. 4 times the square root of 2. Good job, Obina. Tighten it up, Chosen Creeper. Tighten it up. All right. So that is the result of problem number 42. Amen, amen. That's right. God, hey, Chosen Creeper, you said that radicals seem a bit confusing. Check out my video called Simplifying Square Roots, Chosen Creeper, because I have many, many examples to show you how to simplify those square root signs. All right. And one thing I'd tell you that's a good, helpful thing to do is to go ahead and memorize like the first 25 perfect squares. If you know you're going to have a lot of math classes coming down the pipe, know the first 25 perfect squares. So all the way from 1 squared is 1, all the way to 25 squared, which is 625. Know those for memory because it'll help you and you'll be a much more efficient mathematician. All right. So there you have it, guys, for problem number 42. Let's move on to our next problem. And as we do that, we're going to have a reminder to set up a paid online tutorial today with Mr. Witt. So if you ever need one-on-one help, guys, and you don't have anybody in your family or at your school at the ready to assist you, then thanks very much, Angry Hermit, for that link. Then you can always set up a paid online one-on-one tutorial with me, Mr. Witt. Just go to the YouTube channel for a link there to our website, or you can go directly there by going to tutormemath.net. And we have very, very fair prices. That's right, for our one-on-one tutorials. That's right. So get tutored directly from me, Mr. Witt, by going to tutormemath.net. All right. Next problem, guys, is problem number 43. Obina says, find a perfect square factor. Can you complete the process? Perfect square. Can you complete the process? What do you mean by that, Obina? Are you talking about factoring a perfect square trinomial? Yeah, I have a video on that, Obina, if that's what you're referring to. Or you talk about doing the prime factorization. Prime factorization is another way to break down that radical, Obina. So using prime factorization, you can do that, if that's what you're talking about. All right. Chosen Creeper got that smiley face, so he understands where he can find his help. 43, guys. Let's check out this problem here. It says to find the missing segment, and what you're looking at, guys, is you're looking at a secant line and a tangent line that have a common endpoint. All right, so it's called the secant-tangent product theorem. The secant-tangent product theorem. And so this is the theorem right here. So if I'm trying to find out this value of x within the circle, this is the way I can set it up, guys. I can set it up just like this. I can say that this total length here, the x plus 9 times the value of 9 here, this distance here, it has to be equivalent to our tangent segment here squared. All right, so this is our setup. We have x plus 9 times 9 equals to 15 squared. Angry Hermit says, what are we doing on Thursday? Thursday is going to be the Algebra 2 final exam review. It's going to be very, very similar to the college algebra final exam review. So if any of you guys needed extra help with your college algebra classes, you can check out that Algebra 2 final exam review because it's going to be very, very similar to that previous one. But, of course, it will have all different problems. Three Musketeers says, wouldn't the problem have to say assume that all segments that appear to be tangent are tangent for us to be able to use that theorem? Admittedly, Three Musketeers, my diagram is not on point, clearly. But the actual diagram that you would have on your test would definitely be tangent. It doesn't necessarily have to say that. It can just be a better diagram. And so we are assuming that what appears to be tangent is tangent. But on your actual standardized test, I'm pretty sure the diagram is going to be on point. So it'll be clear that it's tangent. So it doesn't necessarily have to say that. All right. It's not a must. It helps. It definitely helps the student to say that. But they don't have to say that. All right, good deal. All right, let's go ahead and move forward, guys. What I'm going to do here is the following. In simplifying this, I'm going to say that I have the x plus 9 times 9 being equivalent to 225. With this, I'm going to be dividing both sides by 9. So I could have gotten my arrows popping, guys, and distributed that 9 to the left side, but I did realize that 15 squared was going to give us 225, which is going to be divisible by 9. So I was being lazy, because that's always going to be my driving force in doing every problem that I do. So I'm looking at the easiest way to get to the answer. So I didn't distribute on purpose because I knew that this value of 9 would go evenly into 225. I believe it's 16. No, it's not 16. Let's figure out what this is. 9 goes into 225. That's going to be twice. It's going to be 18. That's going to be 45. It's going to be 25 times. Should have known that. I should have known that. So subtracting 9 to both sides, you end up with x being 16, guys. X is 16, and it'll be 16 units to the first power. 16 units to the first power using the secant-tangent product theorem. Good job. Good job, ladies and gentlemen. So, Bina, you're correct as far as it being 16 units as far as solving for our value of x. That's right. That's right. Thanks, Sim for helping me out with the 225 divided by 9 being 25. I appreciate that. Good job having my back. Sim coming in, being helpful. Good job. All right. We have problem number 44 is next, guys. Problem number 44 is next. All right. Three Musketeers. We are assuming that all segments that appear to be tangent are tangent. That's what we're doing. That was for you, Three Musketeers. All right. So let's find the missing arc. Here, in order to find out the missing arc here, this x degrees that we're looking for, of this major arc, okay, that's what we're trying to find here, whereas the minor arc, we don't know. So before we even go into this problem, we know that as far as the measurements of arcs are concerned, the entire circle has 360 degrees. All right. The major arc here is claiming to claim x degrees of the 360 degrees that we have in the entire circle. So the minor arc has to be the difference of 360 degrees and our known value of x. Okay, so that's what we need to know going into this problem. From here, we can use the following formula, guys. All right, as you see, I have my notes here for you. That in order to set up our equation, we know that this angle measurement up here, this 35 degrees, it has to be equivalent to half of the difference of the major arc, which is x in this case, minus our value of the minor arc, which is 360 degrees minus x. So this is going to be my initial setup for this problem. Amen, amen. And I'm going to go ahead and do two things here, guys, because we're kind of short on space for this page. I really don't want to go to another page here. What we'll do is we'll go ahead and multiply both sides by 2. So I'll end up with 70 equals 2. We know that 2 times a half is a whole, right? So we'll be bringing down x, and then we'll distribute this negative here. I'm getting my arrows popping to get a negative 360 plus x here. All right. So what occurred, guys, is that I multiplied both sides by 2. All right. And 2 times 35 gave me my 70. 2 times a half is 1. So all I had to do from here is start simplifying the parentheses within. I distributed that negative. So I brought down the x. This became a negative 360. And then the opposite of negative x is positive x. And this is where we're at right now. Combining our like terms, guys. We have 70 equals 2x minus 360 degrees. And from here, we'll be adding 360 to both sides. Okay, looks like we got a cross here instead of a plus sign. So we'll be adding 360 to both sides here. There we go, there we go. We end up with 430 being equivalent to 2x. And then we'll be dividing both sides by 2 to find out our value of the missing arc. So our value, guys, for x is going to be 215 degrees. Is that correct, guys? Is the answer 215 degrees? Go ahead and let me know. Three Musketeers says that the answer is 215 degrees. Great job, Three Musketeers. Appreciate you being my favorite candy bar. Obina has 215 degrees. Cosigning. Appreciate that, Obina. Good job, guys. So that's how you find out that missing one there. Chosen Creeper says, yeah, to cosign as well. Good stuff, good stuff. So that was 44, guys. What's next is 45. 45, they want us to find the value of x. In 45, they want us to find out the value of x. We got Simone saying yes. Thank you very much, Simone, for verifying that previous response. Keep me honest, guys. I need you. So here, with problem number 45, guys, we're dealing with a major arc. That is going to be equivalent to 298 degrees. We also are given a central angle, guys. And what you should know about central angles is that central angles are equivalent. They're identical to the arc that it captures. So since we have a central angle of x degrees, the arc that it captures must also be x degrees. Absolutely. And in addition to that, we already said that the total amount of degrees in a circle is 360 degrees. So our equation can be set up as follows. We can say that we have 360 degrees must be equal to 298 degrees plus x degrees. And then solve for x in this problem. All right. So let's do just that. We'll go ahead and subtract 298 to both sides. To solve for x, we'll need to borrow from the 6. We know that 10 minus 8 is 2. We had to borrow from the 3. That gives us a 2, Mr. Witt. There you go. 15 minus 9 gives me 6. So you're absolutely correct, Chosen Creeper, in saying that the answer is 62 degrees, guys. The answer is 62 degrees. Done and done. Let's go ahead and move this out of the way. Let's put that over there. Let's put our 62 degrees right here and red box it. So that's being familiar with your central angles. Three Musketeers has the answer there. Obina has the answer there. Good job, guys. And of course, Chosen Creeper with the 62 degrees. That is absolutely correct. Good job, guys. That was problem number 45. We are moving along. We are moving along as we are reviewing. This is part 2 of the geometry final exam review. Good stuff, Sim being positive. We want to find the missing arc, guys. We want to find the missing arc. Let me go ahead and give you some notes on this real quick on the side here. As you see that the captured angle here, the captured angle in this diagram is equivalent to half of the difference of the larger captured arc minus the smaller captured arc. That's right. So we can set up an equation that reads 26 equals half of the difference of the larger arc that's captured, which is x, minus the smaller captured arc, which is 13. So here we have our setup, just like that. Then let's go ahead and multiply both sides by 2. This time I'll show it, guys, because I neglected to show it the last time I used a problem similar to this. I want to show it to you this time. So we're going to have 2 times 26 is going to give us 52. This equals to the 2's cancel out to bring down that x minus 13. We will then add 13 to both sides of the equal sign from here, guys. And we'll figure out that 52 plus the 13 gives us 65 degrees as our value of x. This is the value of the missing arc. And we will red box it. Red boxing it. All right. Chosen Creeper says that this should be 39 degrees. Obina says this should be 39 degrees. Did I do something wrong, guys? There you go. You subtracted instead of adding. That's right. You should add 13 to both sides. Obina and Chosen Creeper. Okay. So go ahead and verify that I did that right, guys. 3 Musketeers is co-signing. That's right. Sorry about that, Obina. That's right. Obina and Chosen Creeper, y'all jinxed one another. you jinxed one another, guys, on that one. Good deal. Yeah, so just making sure we have the process correct. We set it up as 26 equals to 1/2 the difference of the arcs, the captured arcs, the larger one minus the smaller one. I multiply both sides by 2. 2 times 26 is 52. 2 times 1/2 is 1, so I bring down the x minus 13. In order to isolate x, we need to add 13 to both sides of the equal sign. 52 plus 13 is 65. And that's right, Obina. This is why we showed the work. Good deal. Simone says, for clarification, when you say captured arc is just a triangle on top of a circle. No. This is what I mean by a captured arc, Simone. Notice that we have this angle here, right? Okay. Referring to the circle, the captured arcs are right here and right here. these arcs are captured by the intersecting angle. That's what I'm talking about. All right, so I'm talking about the length of this arc going around the circle and the length of this arc going around the circle here. They can be defined by lengths, exact lengths, and they can also be defined as a ratio in the form of the degrees of the circle that it represents. So that's what we're referring to on that one, Simone. That's an excellent question. So yes, when I'm talking about captured arcs, I'm referring to the actual pieces of the circle that this angle is intersecting with. That's what I'm talking about. All right. Hopefully that clarifies that for you. But great question nonetheless. That was problem number 46, guys. Let's move on to problem number 47. And problem number 47, guys, we have to find the missing angle. All right. And Simone says she understood that last one. Fantastic. Well, guys, here we are going to be utilizing the notes right here that will inform you that in order to find out this angle here in this intersection, we need to take half of the sum of the arcs that these intersections are capturing, Simone. That's right. So in order to set this up, I know that angle 1, in this case it would be x degrees, that x needs to be equivalent to half of the sum of these arcs. So we have 210 plus 15, and we're going to add these together first. All right. So we'll have half of 210 plus 15. That gives us 225, correct? And then we want to take half of 225, guys, in order to find out this result. So let's go ahead. You know how we are with my long division today, guys. I'm going to have to represent because I jacked up the beginning. We have 2 going into 2 one time. Subtract, bring down the 2. We got 2 going into 2 one time. We subtract, we bring down a 5. All right, 2 goes into 5 twice. Add a 0. After that goes into that 4 times. So that's going to be 112 and 5/10. All right, good deal. 3 Musketeers, good job. Angry Hermit, thank you so much for stopping by. Take care. I appreciate you. Angry Hermit says she'll be back on Thursday, guys. That's what's up. So we end up with 112 and 5/10 degrees, guys. Is this correct? Did I finally divide right using long division? All right. Chosen Creeper says that the batteries ran out. Don't let your batteries run out there. All right. Sim being cordial. I appreciate you, Sim. You can come by anytime. Good stuff. Good deal. Take care, Obina. Thank you so much. I appreciate you. Thank you for stopping by today. Good stuff. So, here we go, guys. That was the answer for problem 47. Finally, guys, we have our last problem of the final exam review for geometry, and it is problem number 48. And with problem number 48, guys, I'm pretty happy about this because I'm going to show you my method that I've never shown anybody on the YouTube channel before, and it is my Goldilocks method for solving problems like this. That's right. We're going to call it the Goldilocks method for solving problems of this type. Now, why do I call it the Goldilocks method? Because I'm going to have a Papa Bear, a Mama Bear, and a Baby Bear in this problem. That's right. So we're going to start out by labeling the Papa Bear as the biggest triangle, guys. So we have A, we have C, we have B. That's going to be Papa Bear. Mama Bear is going to be the middle-sized triangle. So she will be labeled B, D, and A. And then we'll have the Baby Bear as the smallest triangle. Will be labeled as A, D, C. Once again, I am defining this method, guys, as the Goldilocks method. That's right. Made up by Mr. Witt. First time you seeing it. Papa Bear, Mama Bear, Baby Bear. There you go. So check it out, guys. They already told us that AC was going to be equivalent to 12, whereas BD is equivalent to 7. All right, let's see how this helps us out. They want us to find CD, which we don't know. We'll call that X. They also want us to find AD, which we don't know. We'll call that Y. All right, let's get popping, guys, with the Goldilocks method from Mr. Witt. You're seeing it live and brand new. So let's go ahead and fill in our values on our Papa Bear, Mama Bear, Baby Bear. So everywhere we see an AC, guys, AC is going to be the length of 12. We got a length of 12 right here. Every time we see DC, that value is X. All right. Every time we see AD, that value is going to be Y. And every time we see BD, that value is going to be 7. All right. Amen. Amen. So this is what we have thus far, guys. This is what we have thus far. Let's see if we have enough information going on here to get things on and popping. We got our AC value is 12. True, true, true. We got our BD value is going to be 7. All right. Let's make sure we got everything lined up right. That's going to be B, C. Oh, there you go. Here we go, guys. BC is going to be equivalent to X plus 7. Let's go ahead and say that. That BC is equivalent to X plus 7. That's important as we label this out. As we label this out, it is important to note that the total length of BC is equivalent to X plus 7. There we go. That's going to be important. There you go. Dan in the house. What's going on, Dan? All right, so we got our Papa Bear, Mama Bear, Baby Bear labeled, and we're going to be using proportions, guys. All of these triangles are proportionate to one another. They're similar triangles. So because of that, we can use the extremes means to set this up. We can use proportions to set it up. In other words, I can say that X plus 7 is to 12 as 12 is to X. Setting that up. Let's go ahead and add a page or two to this, guys, as we set this problem up here. I'm going to need some room to move. I need some room to get this done. All right. Because I'm excited to show you guys this. Never showed you guys this method from me before. So let's go ahead and make this on and popping. We had this set up as X plus 7 over 12 equals to 12 over X. Let's go ahead and solve for this now. Let's go ahead and hook this up. Hopefully I don't make any mistakes. Don't want to make any mistakes with this. All right, here we go. So solving this, we have the following. Take care, Dan. All right. Study some calculus on some other FBT videos. I hear you, Dan. I'm going to get some more calculus videos up soon. Let's go ahead and use the extremes means method, guys. So we'll end up with X times X plus 7 equals to 144. That's 12 times 12, right? We'll go ahead and distribute. We got our arrows popping. There's going to be X squared plus 7X equals to 144. We're going to subtract 144 to both sides, like so. We'll have X squared plus 7X minus 144 equals 0. We need two factors of 144 that'll subtract to give you 7, guys. That's going to be 16 and 9. So we'll have X plus 16 times X minus 9 to equal to 0. And then we're going to solve for this. Solving for this, we'll have X plus 16 equals 0, as well as X minus 9 equals 0, using the 0 factor property. If you subtract 16 to both sides, you'll get a potential length of negative 16. Solving the second equation, you'll get a potential length of 9. However, guys, you need to keep in mind that we're dealing with geometric shapes. You're not going to have any negative lengths, so it can't be negative 16. This answer has to be positive 9. So as we refer back to the Papa Bear, Baby Bear, and the Mama Bear, we just solve for X, knowing that X is equal to CD, and CD we just solved for is 9. So that's that value. The value of X is 9. Therefore, the value of CD is 9, and we will red box it. However, we're not done. Oh no, we're not done at all. Let's go ahead and take this result, guys. Take our diagram, because we need to also solve for the length AD. We need to also solve for our length AD. So let's hook this up. So what have we learned thus far? We have learned the total of all the triangles have to equal to 180. That is talking about the interior angles, not the side lengths. The angles of all the triangles do add to 180 degrees. Those are the interior angles, Simone. Take care, Sim. Thanks a lot for stopping by today. I appreciate it. So here, guys, we just solved for x, and x is 9. So let's go ahead and put that in, that we know that this is 9 now. And we're finally going to solve for AD. And if we're solving for AD, guys, notice that we now have 2 lengths out of a right triangle. We have 2 out of 3 sides here, guys. So with these 2 out of 3 sides, we can solve for this value of y, the AD length, by using the Pythagorean theorem. So with the Pythagorean theorem, you know, is going to be a squared plus b squared equals a c squared. Well, in this case, we'll say that y squared plus 9 squared is going to equal to 12 squared. Knowing this, we'll have y squared plus 81 equals to 144. You'll subtract 81 to both sides, right? To get y squared equals to, let's go ahead and subtract here. We got a 3 right here. We got 14 minus the 8. That's going to give us 6, right? So we have y squared equals to 63. Good job, Three Musketeers. We recognize that we needed to use the Pythagorean theorem. You'll have the square root of y squared here, and this will be the square root of 63, which we could expand to show our largest perfect square within 63 is 9. So that gives us 9 times 7. So your value of y, guys, is going to be 3 times the square root of 7. So this is going to be our length of AD. Since AD equals to y, that value is going to be equivalent to 3 times the square root of 7. And we have our answers for problem number 48, guys. Done and done. That's right. Yeah. We have completely answered the question to problem number 48. And we started out by using the Goldilocks method from Mr. Witt. Papa bear, mama bear, baby bear. That's right. That's how we solved it. And Chosen Creeper is requesting a cube for our answer here. There we go. The red cube is in the house. Boom. There you go, Chosen Creeper. We got a red cube for you, sir. We have a red cube to box up our answer for the length of AD. Well, ladies and gentlemen, this has been the second part of the Geometry Final Exam Review, the end of course second semester final exam review for geometry. As always, please rate, comment, and subscribe, guys. Thank you so much for joining us today. I appreciate that. Click on that bell icon in order to get a notification when we go live next, and also when we upload new content. That's right, Simone. That is the Red Box 2.0. Absolutely, guys. You guys have been wonderful today. Thank you so much for helping me out, keeping me honest on our answers today, guys, and for sharing the stream to the people that you know and love. Three Musketeers, appreciate you chiming in today. Sim, appreciate you coming by. We had Three Musketeers in the house. Chosen Creeper, of course. We also had Dan coming in. Angry Hermit coming in. We had Obina in the house. That's right. We had all of my peeps coming through today, guys. We had Dan in here. We had Jamila in here. That's right. And all of the above. Swag Wave stopped by for a little bit. Rudy was here. Tony and Noah was here. Good stuff, guys. Thank you so much, guys, for stopping by, spending time with me. And I will see you soon with more free math tutorials from me, Mr. Witt, and Fort Bend Tutoring. Peace. Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh yeah, baby.